Hello everybody, this is the second part of the first tutorial, which is how to use Visual SFM in order to get a proper scan of the human body, in this case my face. And it's follow-up of the Visual SFM, because Visual SFM it's a nice software that can run on Mac operating system, and it's actually the only one I found that runs on Mac operating system. And so if you have a Mac, you're stuck with that. And it's the second step, because Visual SFM just provides us a point cloud. So we will need another software to go inside that point cloud and transform it into a 3D model that we can use on other software. So Meshlab, it's a very powerful software that I suggest you also for doing other stuff. So as you can see here, it's make a lot of nice stuff. Okay, and as you can see here, there are a lot of features, a lot of tutorial. So go to meshlab.net to see the full potential of it. It's proudly made by the Institute of Science and Technology EIFA-EDO, which is based on Pisa, Italy. And I'm really proud of that, because it's really one of the best software I've found for mesh editing. It's just slightly bit on the nerdy side, but it's a really powerful one. So you can go to download section and just download for Windows, macOS, Linux, whatever. And we're gonna open the model folder that we have created with Visual SFM. And so if you already didn't associate, just open with Meshlab. And we have this here. And you already see my face. This is the right side of it. So right now this seems a model, but actually it's a 3D point cloud, which is the first thing you're gonna find with every 3D scanner. The first output will always be a point cloud, except the part that you have done with Alberto, which is from the MRI scanner, which is based on pixel and voxel. So it's kind of a bit different, but all the other 3D scanners start from a point cloud, actually. So we're gonna transform this into a 3D model, and we're gonna scale it up until it's on the right measure. Okay, so we can start from the scaling, which is the easier part. We can measure from this dot, if you can see it on my face, and this other dot here, which is the 2 points I've taken to make the scaling part. So as you can see in this layer editor, if you don't see this part of the interface, you just switch it on like this. And we are using the measure tool right now to get this 0.5, it's the distance between those 2 points. Okay, so we take the calculator, and I know that that distance is 104 millimeter. So we divide this number by, I didn't copy that number before, okay. So we divide this by 0.5508. So we need to scale it up by 186%. So because Meshlab doesn't have scaled based on typing just the scale, and I have to do that by dragging the mouse, I will do first 1.8 and then scale it up by 10, and then scale it up by 10 again to get this number of scaling. Okay, so we can keep our calculator on the side. Meshlab on the other side and try to scale it up properly. Just want to see this number. Okay, so we are still inside the measurement tool, so we need to unclick this to unlock the other feature. And the first thing we are going to use is show the coordinate system. And this ball you can see here, it's not actually the coordinate system, just a ball to rotate the view. It's always in the same position compared to the model. So I'm not moving the model, actually I'm just moving the camera, and this stays in the same position. Since I'm a bit confused about this interface, I just hide this, show the X and Y axis because it's the one we need. All the scaling and the transform will be applied depending on this origin, which is actually the model origin. So all the points are described starting from this point. So we need to place this around the center of the model. I like to place it around the eyes because it's one of the most precise part of the human face, and especially my face, because I have a very nose that it's pointing to the right, so it's not so accurate for measurement. And so what we're gonna do, we have highlighted the axis. Now we clicked on this button, which is manipulators, and we have these parts on top left that says press T to translate, R to rotate, S to scale. So we wanna translate at the moment, and we can, sorry, can hit S, go back here. I don't know if I've done something wrong, so I reset current matrix, apply, and again here. So T for translate, okay, and I need to move this around here, and then I hit enter and unclick this. No, wrong. So it's better if we position ourselves from top and put the view into orthographic camera, which is easier to see from top. So just align with the view, and again translate T, and I move my face to the origin, and then enter to terminate the command. So now I can unclick here, rotate my view again, position from the front view, align with the Z axis in my case, or whatever axis you are working on, zoom in a little, and again aligning a bit better with the Z axis, and now I can make another movement. So again, manipulator tool, T to translate, and I move my eyes close to the red line and enter. Then I hit rotate R, and I should see I'm rotating around a strange point. So hit S, and enter. I need to move back, here, move back to translate. Okay, it's correct right now. Okay, enter. When we have applied, we want to apply transformation definitely and reset the origin of all the point cloud. We need to go here and matrix, freeze current matrix. This means the transformation we have done until now, it's kind of temporary. It's like a deformation matrix which is applied on our actual point cloud that is not deformed at all, and we need to make this deformation matrix definitive. So we need to right click on our layer and hit on matrix freeze current matrix. This will apply the transformation to our tool. So when we switch back to rotate again, you will see that it's not going inside the rotate action. Okay, right now it worked. You can see the origin of the rotation now, it's the center. So it's my origin. I needed to apply the transformation for this to happen. Okay, so rotate again, and before entering the rotation I will come a bit closer to my model so it's easier to see the eyes. For any movement you need, this is not so good for Meshlab, unclick the button, because when you are inside one of the tool you cannot move. So it's not so easy to understand at the beginning. And now again I hit rotate. If I look here, there is we can press X, Y or Z to select an axis around which to rotate. So the red one is the X, the green one is the Y, and the one we cannot see, it's the blue one, which is the Z. So I hit Z, and then I can just rotate around the blue axis. So I need to find the proper alignment of my pupils to the red line. So I go like this, fine, with enter, and again we go to layer and matrix freeze current matrix, apply, and we are almost done with transformation. I just need to put the model a bit more with translate with on the red axis, which is X, a bit more to the center. So I want to place the eyes exactly in between the green line. As you can see, my nose is not exactly straight, but we would refer to the eyes, which are more precise. Okay, with enter again, matrix freeze current matrix, apply. Okay, last step, we scale the model up as we were trying to do before. If we measure here again, we will get the same number because we didn't scale, so we can just use again the scale we calculated before. So we did 104 divided by this measure here. So this will provide us the scale for our model. So we need to make it 100 times 86 more big. Okay, and so we go back to, we go out from measure, we go back into manipulator. This time it's scale, and we just want to do uniform scaling, so we just click and enlarge until we are into 1.86, which is the small number you can see here. And okay, so we are pretty close. I think it's enough. 186.8, this is 1.867, so it's really close. Just change 1 unit here and enter. Didn't catch the enter. Okay, so we are now back into the tool. Again, scale. The scaling factor is resetted, so we can go to 10. In the option you can see hold shift to snap, so we hold shift and drag, so we can move about just more precise numbers. So we just go till 10, precisely 10, and then enter again. and then we can reset the view here if you need that. Reset trackball if I remember well. And again scale, and again scale up holding shift of 10. Okay, we're done. Enter out of this tool. We can zoom out a little. We can turn the face, which is nicely in the middle of our origin, and matrix, freeze current matrix. Apply. Done. Okay, so for the scaling part we are done. We can check it, double check it. So I click again on this point, again on this other point. 104 millimeter. Fine. I can measure also this other cross mark here and this around here. I turn around a little to see if I catch the right point. Yeah, it's in the middle of this cross. It's barely visible, but it's there. This is a bit more. And as you can see, the second point is 91. This number should be 88, but it's just 3 millimeter away from this being the right point. As you can see here, I've not clicked exactly in the middle, a bit farther away. So this is an acceptable scaling issue, and it's fine. So next step, it's meshing these point clouds. So we're going to find an algorithm that can connect all these points together to get a nicer mesh. So I already know that the tool we need it's Poisson surface reconstruction screened Poisson. You can use this search tool to find it easily. Actually, we will need for bigger point clouds to drive before a Poisson disk sampling, which is downsampling our point cloud. But this is a point cloud which is not too heavy to handle, so we can just run screen Poisson from start. Before doing that, I prefer to save my file because I'm not sure about it crashing it. So can save a Meshlab project file on my same folder I'm working on right now, which is inside here. So small reconstruct. Okay. And now we're gonna run. Before running the Poisson disk sampling, it's better if we remove all this data. We don't need this point cloud around here. So we can do that going out from this tool again to highlight the other one. Then we select with a rectangle marker here and just delete the points. Again, select or go here. Again, select, delete, turn around, select, delete, and also this part I don't need. Turn around. Okay, better. And also these per points. And this part here. Okay, nicer. And what I'm gonna do now is try with the surface reconstruction pre-screened Poisson. All these filters, you can find them in filter here. So this program is really full of hard geometric mathematics. and you can do really a lot of stuff in smoothing, colors, remeshing, subdivision, whatever you like to do. You just have to know the name of the filter, which is not so easy, but you can find a lot of good tutorial on the website. And so again, filters, remeshing, subdivision, surface reconstruction, screened person. You have to play a little with the tool here. I found that work better 11 reconstruction depth and a minimum number of sample of 4 or 5, around that number. We can apply. Okay, worked nicely. Here, as you can see, we have another layer which is a mesh layer. We can see that because here there is rendering activated on point and this is on faces. We can zoom in, we can see we are seeing both points and meshes. Okay, we are done. So we just need to export this dataset to a file that we can see in Meshmixer. So we need to export the mesh as we can call it the same way, small point cloud or small mesh. And we choose to save in OBJ, which is a very good exchange file. Save, and we want to save the colors and the normal. Okay, we are done. Okay, we go back to our model inside subset small, and we can see we have the model small mesh. We can try to open that in Meshmixer to see if everything works correctly. Okay, we have a mesh here. We can view the printer bed, which is the printer bed of MakerBot Replicator 2, which is 20 centimeter by 40. And you can see that my face barely fit inside, which is correct because it's slightly bigger than the build platform. I can rotate that of 90 degrees because it's more convenient to see in Meshmixer. And we can put the origin here, which is in the middle of my eyes again. Accept. We have lost the texture in the process, but it's not really needed for what we want to do. With the other software that we are doing for Windows, it's a bit nicer and scary at the same time, because with the texture you can work actually with my face, and it's a bit more strange than this. So I just hide the printer bed, and that's it. We are done with this tutorial. So in the next step we will see Zephyr, which is the software I choose for Windows user, which is a bit more refined, as you will see, has software, and much easier to work with. Has still some complexity, but it's I prefer that a bit more. So if you are a Linux user, I would suggest to use Mushroom. If you are a Windows user, I would suggest to use Zephyr, and if you are Mac user, I think you are stuck with Visual SFM. So bye bye, see you in the next tutorial and in the next lesson, which will be Custom Orthotics for design and healthcare. Okay, bye.